Hi everyone, welcome back to Life Technologies YouTube channel, and thank you so much for watching and supporting our content. So this is another episode of our Huawei Lab simulation series. Remember, in this series we discuss how to implement different networking protocols or different networking technologies on Huawei routing and switching devices. So we've covered a lot in our previous 32 episodes. If you haven't watched them, kindly check them out on our channel and have a look at them. We also have another series of how to implement on Nokia routing and switching devices, and another series on IP run for service provider networks. So if you haven't watched our previous episodes or videos, kindly check them out on this channel, and you'll be able to learn how to configure, how to troubleshoot and implement different networking protocols on technologies on Nokia and Huawei routing devices. So in this episode, we'll be focusing on how to implement VRRP on Huawei routing devices. So we know that for a network, we need to consider the reliability of the network, the redundancy of the network. So we have many protocols that can be used to ensure network reliability. So we have what we call the first Hop Redundancy Protocol, FHRP. So FHRP provides redundant gateways for IP networks. So you can imagine if you are service or you are service provider and you are connected only to one gateway. Whenever the gateway fails, you end up not having connection to the internet. So first hop redundancy protocols ensures that we have redundant gateways for the customer network to the internet. So whenever there is a failure, the network is able to switch from the primary gateway to the backup gateway, and there is continuity in service, or we are not affected whenever there is a fault in the network. So there are many fast hop redundancy protocols. We have the industry standard and also some proprietary protocols. So we have VRRP. VRRP stands for Virtual Router Redundancy Protocol. This is the industry standard fast hop redundancy protocol. So it is vendor neutral. You can configure it on Huawei, you can configure it on Cisco, you can configure it on Juniper, Nokia, and any other vendor that supports VRRP, because that is the industry standard fast hop redundancy protocol. And then we have HSRP. So HSRP is only Cisco protocol, and it stands for Hot Standby Redundancy Protocol. So Hot Standby Redundancy Protocol can only be implemented on Cisco devices, either Cisco routers or Cisco switches or firewalls or any other Cisco device that supports HSRP. So I've mentioned that in this episode we are focusing on VRRP, that is the industry standard fast hop redundancy protocol. VRRP, this is a fault-tolerant protocol, and it groups several physical routing devices into a virtual router. So we are taking two devices or two gateways, and then we are grouping them into a virtual router. So the virtual router will switch traffic from the master device to the backup devices when there is a failure in the network. So once we have grouped them, we have two roles. We have the master device and then we have the backup. So the two devices will be backing up each other. Whenever there is a fault, the traffic is able to switch from master to the backup. So this one ensures that we have service continuity and reliability will not be impacted whenever there is a fault on one gateway. So how do we select the master and the backup? The selection process is based on priority. So we configure device priority on the master and the backup. And the device with the higher priority is always selected as the master. And then whenever there is a failure, this traffic will be able to switch to the backup device configured with lower priority. And sometimes you can also configure preemption. So preemption means when a fault occurs and the device, maybe the master went off or maybe there is a power issue, and then backup took over. When the power is restored on the master device, the traffic should be able to switch to the master. So there is preemption. The master takes over again from the backup whenever the master is restored. So I've mentioned that in this lab simulation, we'll be focusing on VRRP, and you can see that we have the user network. So you have user network, and the user network is connected to this one. You can see it at the service provider connecting us to the internet. So you can see that we have multiple exit. We have exit 1 and exit 2. And many times we don't want to do manual switchover. So that's why we configure the master and the backup. So the master will be in charge of forwarding the traffic all the way from user to the internet and also internet to the user. But whenever there is a failure, the traffic will be able to switch and use the backup device to the internet. So for the topology, this is the topology that we are using. We have two gateways. We have gateway 1 and gateway 2, and then we have the customer edge device. So the customer edge device is connecting to one PC, and all our tests will be done from the PC. So the customer edge device connects to gateway 1 and gateway 2. And we also have the internet gateway connecting to the internet. So we need to set up gateway 1 and gateway 2 in a way that they are backing up each other. So this one will be our virtual router group. And then this will be the router, but this one will be configuring it as a layer 2 so that we only pass VLANs and then we can pick our gateways from these devices. So we have the virtual IP. The virtual IP will be 20.20.20.254, which will be configured on both routers, and then we have the IPs for the physical interfaces. For IGP, we'll be using OSPF, so we'll configure OSPF to distribute the routes. Remember, we need to advertise this gateway to this network. We also need to advertise this gateway to this network. So once we've hired OSPF, we can have reachability, and then we can go ahead and implement VRRP to ensure that we have connection to the other side of the network. So to start us with, we'll start by configuring the sysname, and then we can configure interface IPs, and then go ahead and configure OSPF in the network. And once we have done OSPF, we can now implement VRRP in the network. So let's start by configuring the sysname. So this is the internet router. We always have to be in the system view, but I will undo terminal monitor. So you need to be in this configuration view, not the user view, for you to be able to make configuration changes. So sysname, this is the internet. And then for internet gateway, with the router connecting us to the internet, sysname IGW, gateway 2, same sysname, gateway 02. Then this is our CE router connecting to the CE device to the customer network. So it's sysname CE. And finally gateway 1, gateway 01. So we are done configuring the system names on all the routers. Always give a meaningful name to the routers. So the next step of configuration is to now configure the interface IPs. Need to do a terminal monitor so that it doesn't disturb our configurations. So I will start by configuring the interface IPs on these routers. Let me move it this way so that we are able to see the topology. So starting with gateway 1, you can see that we have two interfaces. We have GE001 and GE00 that is connecting to the CE and also to the internet gateway. So I will configure interface gig 0/0/0, and then we give it IP address of 10.10.10.1, mask is 24. Then we need to configure the interface connecting to internet gateway, interface gig 0/0/0. This should be 1. You can see the IP address is 10.10.0. It's 10. Use the IP address command 10.10.10.0. Mask is 31. This is a point-to-point connection. So that is it for that router. We go ahead on gateway 2. So we start by interface. Let me undo the terminal monitor. We need to return and do terminal monitor. we go back to the configuration view again, and then it's interface gig 0/0/0. That is the interface connecting to the CE. We can give it a description, but we'll just configure IP address 20.20.20.2. Mask is still 24. So if you display this, you can see that we only have the IP address. We'll go ahead and configure gig 001. We give it IP address of 10.10. This is 10.10.2. Mask is 31. Display this. You have the IP address assigned. Quit. So you have assigned the IP address correctly. If you display current configuration, you can see that we have our interface configurations here with the IP address that we have assigned. We go ahead and configure the internet gateway. So for the internet gateway, we are configuring 3 interfaces, GE01, GE00, and GE02. Let me also undo terminal monitor. So we'll start by configuring interface gig 0/0/0. We assign IP address of 10.10. This one should be 10.10.1. Mask is 31. Then we need interface gig 001. We'll assign IP address of 10.10.3. Mask is also 31. And finally, the interface connecting to our internet router. This one will be 172.200.200.0. Mask is 31. That is it for the interface configuration. You can display current configuration and check our interface configurations. So these are our interface configurations. And then we need to configure our internet router. So for our internet router, we are only configuring one interface, the one facing to IGW. Undo terminal monitor. Interface gig 0/0/0. The IP address should be 172.200.200.1. Mask is 31. So we are done with our interface configuration. The next step is to configure OSPF on gateway 1 and gateway 2 and the internet routers and advertise the required network. So we'll be configuring OSPF on gateway 1, gateway 2, and the internet gateway router. And then we need to advertise the network so that they are reachable. So we'll start by configuring gateway 1. So we need OSPF 10. Router ID, we can give it 1.1.1. Area 0, and then we need to advertise the network. So we are advertising network 20.20.20 0. Then we are giving the wildcard mask, and then we need to also advertise this network 10.10.0, 10.10.10.0. The wildcard mask is .1. So these are our OSPF configurations on this router. Quit display these. These are the OSPF configuration. We have configured OSPF process 10, route ID, and then the area 0. All routers will be in area 0. So in gateway 2, we need to do the same. OSPF 10, router ID, we'll give it 2.2.2, area 0, and then network 20.20.20.2. Wildcard will be .1, then network 10.10.10.2, 0.0.0.1. Display these. quit, and then display the configurations. So you have your OSPF configurations on gateway 2, and finally on the internet router, I mean on the internet gateway router, OSPF 10, quit first. We need OSPF 10, router ID will be set to 3.3, area is still 0, area 0, and then we are configuring it, the networks, so it's 10.10.10.0.1. This one we have .2, and we are also advertising the network between the IGW and the internet router. So 172.200.200.0. So when we check the OSPF configuration, these are the OSPF configurations. So display OSPF peer. You have two OSPF peers to gateway 1 and gateway 2. If you check on gateway 1, display OSPF peer, you also have one peering session there, and then display OSPF peer, you have one peering session there. So we are done with OSPF configuration. Our peering adjacent these are up. Can display IP routing table, you will have the route. So you can see that we are getting this IP in our OSPF routing table. So once we have done with the OSPF configurations, we now need to go ahead and configure VRRP on gateway 1 and gateway 2. I mentioned that we have the virtual IP of 20.20.20.254. We have already configured the physical interface IPs. So we'll start by configuring VRRP on one of the gateways. Or maybe one thing that we can do is to simulate in case we don't configure VRRP first, what will happen. So whenever you have a failure, the traffic will not switch automatically. You will end up because you have a static gateway configured on the PC. So one thing that we can do, let's configure our CE router. So on the CE router, let me undo terminal monitor. This one will be configured as a switch. So I'll go back to the system view, configuration view. I will create a VLAN 10, and then we'll configure the ports to be port switch. So interface gig 0/0/0, we configure it as a port switch, and then we'll configure the port link type. Port link type access, and then port default VLAN will be set to default VLAN will be set to 10. So display these are the configuration on this port. We also need to do the same for gig 001 and gig 002, I mean Ethernet 00. So what I can do is I can copy this configuration to save on time. Interface gig 0/0/1. I'll paste the same configuration. Quit interface Ethernet 0/0/0. So display these. So you have port link type access, port default VLAN is set to 10. So finally on PC1, given that PC1 you have to configure a static gateway. So you can see that currently we are using 254, but we need to configure it to one of the IP. So we can configure it 20.20. So you see that when there is a failure on either of the gateway, it means we'll have to come and do manual configuration changes so that you are now pointing to gateway 2. So let's test if we can be able to ping. ping. This will be 10. Let's see, this is 2020, so 20.20.20.1. Let's see this, the gateway. Gateway is set 1. We are not able to ping. Let me see this, display this. On this router, let's verify quit. Display IP interface brief. Let me configure interface gig 0/0/0, and I will go ahead and remove the IP address. Display this. You can see that we have configured the wrong IP address on this interface. So the IP address should be 20.20.20.1, mask is 24. Let's try to ping. Command. So we are now able to ping. So many times you always have to be able to troubleshoot. You can see that this one we had configured along a wrong IP address. So you need to be able to identify where you have the issues and be able to fix them. So on gateway 1, we can also verify that display IP interface brief and confirm that we have the right IP addresses configured. We have on gig 0, we have on gig 1. So that is okay. So you can see that whenever we have a failure on this PC or on this forwarding path, we always have to come and manually change the gateway so that it's pointing to gateway 2. But to make it simple, we configure here, we give the virtual gateway of 254, and then we can go ahead and implement VRRP on this router. So on gateway, for us to be able to implement VRRP, we'll be configuring the interface gig 00 and adding a virtual IP. So it's interface gig 0/0/0, and the command is VRRP, and then we need to give it the virtual routing ID. So we'll give it ID of 10, and then we need to also configure the virtual IP. So it's 20.20.20.254. That is it. And given that this one is our master, we need to configure the priority. So by default, we'll see that the priority is set to 100. So we can configure a higher priority on this router so that it will be selected as the master. So we'll configure VRRP and then VRID 10. We assign a priority of 120 or maybe 200. And then finally we can configure preemption mode and configure some delay so that it doesn't switch on. Immediately there is a fault is cleared, the traffic switches immediately. No, we need to configure some delay to allow for the convergence of the network. So we'll configure VRRP and then VRID 10. We run the command preempt mode, and then timer, we give it timer delay off. So you can configure the second that you want it to hold. You can see that by default is 0, so it will switch immediately, but then we can give it a timer of 30 seconds. So whenever the master is restored, it will wait for 30 seconds and then it can switch the traffic back to the master. So these are the configurations. You can see that VRRP ID is configured to 10, the virtual IP is set, and then we have configured the priority of 200, and the preempt mode is enabled, the timer delay 30 seconds. So we need also to configure the same on gateway 2, but for gateway 2 the configuration are simple. We only need to assign the virtual IP. We are not configuring any priorities on this router. So the only command is VRID 10 virtual IP set to 20.20.254, and this is it for router 2, our gateway 2. So once we have done that, we can verify our VRRP status. If you display VRRP brief, you can see that this router is already set to the backup. Let's see if we can see the details. VRRP 10, you can see that priority is set to 100, the virtual IP set to 254, the state is backup, no delay time, preempt is enabled. Yes, preempt is always enabled by default. So on gateway 1, we expect it to be the master, display VRRP brief. You can see that it's the master, and then display VRRP 10. You can see that state is set to master virtual IP. The master IP is 20.20.1, and then priority is set to 200. The configured priority is set to 200, and preempt is also set to yes. Delay time is set to 30 seconds as we have configured, and then we also have the virtual MAC address. So this is how you check. You just run the command display VRRP brief or display VRRP, the VRRP ID, and you'll be able to see the status of VRRP. So now if we were to ping the internet from this router, so we can ping 172.200.200.1, this one. Let's see this. Display IP interface brief 200.0. Let's see if we are able to ping this one. We are not able to ping. Let me see the gateway again. Basic config. The gateway is set to 254. Are we able to ping the point-to-point on this end? 10.10.10.1. So it seems we have a routing issue. .20.20.1. We are able to ping .1. We are able to ping .2. We are able to ping .2. We have OSPF. Let's check whether this one is advertised. We don't have OSPF configured here, but we have OSPF configured here. Display OSPF peer. SPF is up. Display IP routing table. This is direct. I'm assuming the issue we are facing is this router doesn't have a return route from. So what we can do is we can configure OSPF here, OSPF 10, router area 0, and then advertise this network 172.200.200.1.0.0.0.0.1. Display this, display OSPF peer. So you have the route, display IP routing table. You are now getting 10.10, but you are not getting the 20. Why are we not getting the 20? Let's check. Display current configuration, configuration OSPF 20.20.20.0, 10.10. you see we have misconfigured the network. So one thing that we need to do on this network, OSPF 10 area 0, I will undo network 20.20.20.0, and then we need to advertise the network 20.20.20.0 mask is 0.0.0.255. So this is how it should be. On gateway 2 we need to do the same. This one will be network OSPF 10, and then display this. We also misconfigure that one, so we need to area 0 and then undo network 20.20.20.2 mask is 0.0.1 and then network. So now we have the right networks advertised. Let's check whether we have the routes on this router. Yes, we now have the route, but even with that we can disable the OSPF on this router and do OSPF 10. Yes, we don't need it. On this PC, let's try to ping. We are able to. Let's try to ping .172. We should be able to ping 172, 200, 200. So yeah, you always, when you are configuring or implementing any protocols, you always have to understand what could be causing the issue, and it will help you to quickly troubleshoot. You can see that we had misconfigured the interface IP on this router, and then we have misconfigured the network command. So you should be able to quickly identify what is causing the ping or the trace not to work, or what is causing the two networks not to communicate. So that is a skill that comes when you do multiple lab simulations and be able to troubleshoot yourself. So keep doing the labs. So when we trace, you can see that when we trace 172.200.200.1, able to ping. Let me just ping -t, then so our ping is continuous and the traffic is flowing through the master. One thing that we can do now to simulate this is to come here on this router, and we'll shut down the interface facing CE and see whether the traffic is able to switch. So I will interface gig 0/0/0. I will shut down the interface. You can see that we have lost some packets. The switchover will take some time. On the internet, let's see the basic configuration. We have 254. Let's see the status display VRRP brief. This is now the master, gateway 2. Let's see gateway 1, display VRRP brief. So you can see that it's now initialized because we have shut down that interface, so it's not reachable, it's not being considered in the master slave switchover. So once we undo shutdown, this one will continue to be the master for some time, for around 30 seconds. Display VRRP brief. You can see that this is still the backup for 30 seconds. So it will continue to be the backup for 30 seconds, and then traffic will be able to switch over after 30 seconds because preemption is enabled. So it's still the backup, and now it's the master. So after 30 seconds, it's now the master, and now this one should be back to the backup state. So this is how simple it is to implement VRRP. Let me show you the configurations again. Display current configuration interface. 0/0/0. These are the configs. VRRP ID. This is the only command that you have to run on the backup router. But on the main router, the master, you always have to configure the priority and also the delay, the preemption time delay to some value so that it allows the network to converge before traffic switches over to the master. So this is it, guys. This is how to implement VRRP. It's a very common networking protocols used in IP network to ensure that we have redundant gateways. I hope you've enjoyed this session. Please leave your comment in our comment section, like this video, and if you are yet to subscribe, just a kind reminder that kindly subscribe to our channel and stay tuned for more upcoming videos. Thank you and see you in our next episode. Bye.